let's do some practice. So what I've done is just taken the homework problems, changed the numbers, but kept the type of problem the same. So first we have sine of x plus 5. It's important to know that it's not a plus 5 in there with the x. If there's not parentheses, then it's outside like that. Okay, so if you remember, the plus 5 outside of the parentheses, outside of the sine function, is going to move it up 5. From our discussion in class, you should know that. If you want an explanation of all that, then go back to the lecture and we run through it there. But this moves the what we call the midline up 5. So we draw our graph. Okay, I'll draw it for 2 periods. Let's see, we can put all this stuff in here. Period is 2 pi, like a normal sine graph. The midline is going to be y equals 5. Should make this like a colon, not an equal sign. The amplitude, which is capital A, I guess we'll do, is normal, is 1. It's not flipped upside down, nothing else has changed. It's not shifted left or right. It's just shifted up 5. So we'll shift that midline up 5. Put a nice dotted line there just to guide us. And so this midline is like the x-axis, okay? It kind of behaves in the same way. It splits the sine wave kind of in half down the middle. That's why it's called the midline. But its amplitude is still 1 and its period is still 2 pi. So if I were to sketch out a full cycle, let's do 2 cycles. Okay? Then this full cycle right here, where it comes around and starts coming up again, just like it did at the beginning, that would happen at 2 pi, like it normally does. This would happen at 4 pi. Right in the middle there, that'd be 3 pi. In the middle for this one would be pi. Alright, just like normal, this just shifted up 5. Okay, let's see what's happening here. So this is a minus 2 pi over 3 inside the parentheses, so this would be a horizontal shift. So we want to shift it, remember, to the right. Even though it says minus there, it's going to move it to the right, 2 pi over 3. Alright, so draw our axes. The period, still 2 pi. Amplitude, still 1. But there's a horizontal shift, so to the right, 2 pi over 3. So wherever we would normally be, wherever a point would normally be, we're going to shift it to the right, 2 pi over 3. All right, let's see. Its period is 2 pi, so let's put a mark at 2 pi. All right, and let's just, here I have the advantage of having this technology, so I'm going to go up and down and back up again. And then I'm going to take this. This isn't our final graph because this is not shifted to the right 2 pi over 3. So I'm just going to fade it out. And then we're going to shift everything to the right 2 pi over 3. We'll notice that we have this point, this point. These points are pretty key. These guys right here we like to use. The beginning, top, middle again, bottom, and then back to the middle. 5 key points. Okay, so they shift to the right 2 pi over 3. So where would that put everything? Well, that's pretty clear for this one. This one is at 0, right? X is 0. So you're going to move it to the right 2 pi over 3. Let's see where that would be. Well, that would be at 2 pi over 3. So keep repeating myself. So let's see. This is pi over 2, right? Because this would be pi. So let's see. 2 pi over 3 is going to be right about there. It's going to be 2 pi over 3. So this point's going to move over to 2 pi over 3. Okay, this one's at pi over 2. It's going to move to the right 2 pi over 3. Where's that going to be? Well, that's going to be pi over 2 plus 2 pi over 3. We need to get a common denominator, so it's going to be 6. So this is going to be 12 pi over 6 plus, no, 3, sorry. Yeah. No, not 12 pi over 6. 3 pi over 6 plus 4 pi over 6 multiply by 2, multiply by 2, here we multiply by 3 and 3. So now we have 7 pi over 6. Okay, so let's figure out where that would be. This right here would be 3 pi over 2. 7 pi over 6. So that would just be just barely past pi. If you look on your unit circle, remember, here is pi. That'd be 6 pi over 6. 7 pi over 6 is right there. Okay, so just barely past pi. So right about there. Okay, 7 pi over 6. I'm going to put an arrow. Not a lot of room here. Okay, so I'll move this guy over to 7 pi over 6. Right there. Here, I'm going to move this one over, pi plus 2 pi over 3. Okay. Pi plus 2 pi over 3, that's going to be 3 pi over 3 plus 2 pi over 3, that's 5 pi over 3. So this is going to move over to 5 pi over 3. Let's see, 5 pi over 3 would be right about there. So just past 3 pi over 2. So we'll move this guy over. And this guy's, let's see, this one's next. From 3 pi over 2, we're going to move it over 2 pi over 3 to the right. So 3 pi over 2 plus 2 pi over 3. So that's going to be 6 pi over, let's see, no, 9 pi over 6 plus 4 pi over 6. That's going to be 13 pi over 6. 12 pi over 6 would be all the way around the circle, and then 13 pi over 6 would be one more sixth past that. So this one's going to go just a pi over 6 past 2 pi, and this guy is going to move over 2 pi over 3 from here. So let's see, that's 2 pi plus 2 pi over 3. That's going to be 6 pi over 3 plus 2 pi over 3 is going to be 8 pi over 3. Okay, so this would be 5, 6, 7, 8 pi over 3, just past 5 pi over 2. Okay. Let's see, so this would be another pi over 2, pi, 5 pi over 2, and 4 pi. Or that would be 7 pi over 2. This guy is going to move, let's see, that's 2 pi, that's another pi over 2, and a little bit past that. Okay. So our new graph is just shifted to the right 3 pi over 2. Every point moves to the right 3 pi over 2. There we go. So we need to find those key points, move them to the right that much, and then plot our graph through there. All right. You don't have to graph this thing and then move every point over, but you know where your key points are given what your period is. So you know that you got key points at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So you add 2 pi over 3 to all of those, and those are your new key points. Amplitude is still 1. 1 and negative 1, and we're done. Alright, so you'll notice here we have a vertical shift, here we have a horizontal shift, and here we have an amplitude change. Let's call it a change. Okay, so as we graph this, let's start by moving it down. Let's see, we're going to move down 2 and have an amplitude of 5, so we're going to need quite a bit of room down in the bottom part of this graph, so I'll just move this up. Alright, so we're going to move this down to 1, 2. Okay, that's going to be the midline. Remember that from the first problem we did in this homework set. It's going to have an amplitude of 5, so it's going to go up 1, 2, 3, 4, 5. Okay, that's going to be the top of the wave, and 1, 2, 3, 4, 5. And that'll be the bottom of the wave. Top of the wave here at, oh, I didn't do that right. This is at 3, because we started at negative 2 and went up 3. So this would be at negative 7. That's better. Okay, so We could kind of consider like this is done and this is done in a sense if we remember to go up here and down to here for our amplitude, and we start here at the midline. Okay, so what do we have left? We got to shift everything 5 pi over 6 to the left. Okay. But the period is the same because there's no number out in front here, so the period is still 2 pi. All right. So we'd still normally expect to see a point at pi over 2. This is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. But everything moves to the left 5 pi over 6. Okay, so we need to take care of that, move everything over 5 pi over 6. Okay, let's see. Maybe an easier way to do it just visually rather than in the previous example. All right, we're going to start here. We know there should be a point here. It would normally kind of come down like this and go up like that as we go into the negative angles. So, but instead of that, we're going to move it to the left 5 pi over 6. Well, there should be 3 pi over 6s in every pi over 2. So this would be pi over 6, 2 pi over 6, that'd be pi over 3, 3 pi over 6, 5 pi over 6, 7 pi over 6, and we can count it off like that. So we'll move over 1, 2, 3, 4, 5 pi over 6 and put a point right there. Okay. Then there would be a point down here at negative pi over 2, negative 1. So move that over 5 pi over 6 to the left. This would be 1, 2, 3, 4, 5 pi over 6 to the left. Okay. And then normally we'd have another point here, like it would go normally like this and up and go up to here, right? To its, I guess we should be coming all the way down here. But normally there would be a maximum here above, let's see, yeah, above 3 pi over 2. We're going to move it to the left 5 pi over 6. 1, 2, 3, 4, 5. Let's see, that is going to be, let's see, another pi over 2, negative 5 pi over 2. Okay, so let's come back here. So far we have translated these 2 points where we come down like this, come down like that. Okay, so, oh, we didn't even do this one. So we're going to move at this point over negative 5 pi over 6. 1, 2, 3, 4, 5. Okay, and that will be, these should be in different places. These should be on our midline. Okay, so we'll move this down here. This should be down at the very bottom. This should be on the midline as well. Okay, now we should come all the way up to our maximum. Okay, so we have come down and back up like this. All right, move this point over, this point over 5 pi over 6. We moved this point that would be down here over 5 pi over 6. There would normally be a point right here at pi on the midline. We moved it over 5 pi over 6. Okay, then next we would have a point right above here, above 3 pi over 2 at its maximum, but we're going to move it to the left 5 pi over 6. We're going to move this to the left. 1, 2, 3, 4, 5 pi over 6. So right around there. All right. And the last one, okay, we would come down all the way up and then back down to the midline again. And normally that would be like right in here. It would go down, up, and then back down at 2 pi. At 2 pi, we would come back to our midline. We're going to move to the left 5 pi over 6. We're going to move to the left 1, 2, 3, 4, 5 pi over 6 and be back at the midline. All right, so there we go. That's not going to be wavy enough. All right. So we have moved it down 2, given it an amplitude of 5. That's 5 above the midline and 5 below the midline. And moved it to the left 5 pi over 6. All right, number 20. So what do we have here going on? We got a vertical shift of 4. We're going to move to the left 3 pi over 2, And this guy changes the period. When you have something times the parentheses with x in it, something times the parentheses with x in it, then it changes the period, as opposed to something times the sign, which would change the amplitude. Okay. So let's incorporate all that stuff into a graph. Let's shift it up 4. It'd be an easy thing to show. Pretty awful. So you can almost check that off. We've shifted it up 4. It's got an amplitude of 1, so you know, the amplitude hasn't changed. It's going to go up to 5 and down as far as 3, because this is 4. It's got the amplitude taken care of. Let's see. Let's deal with the period. We'll mark off some points with that given period, and then we will shift it horizontally. All right, so let's find the period. The period is 2 pi over b, which is 3. Well, that was easy. The period is 2 pi over 3. Not difficult. So the period is 2 pi over 3, which means if we were to sketch out a full period, which we want to give ourselves some room to make this graph, then the full period would happen at 2 pi over 3. All right, where would this be? Well, this would just be pi over 3. Just be half of that. This would be half of that. That'd be pi over 6. And half of that would be halfway between here and there. This would be 2, 3 pi over 6. Okay, so that's where all of our points would be normally. Then we're going to shift all of these points, this guy, this one, this one, and this one. I'm going to shift them all to the left, 3 pi over 2. Okay. So I'm just going to have to do a little math here. We're going to take each of these and subtract 3 pi over 2 so that it shifts them all over 3 pi over 2. Okay. So pi over 6 minus 3 pi over 2. That's pi over 6, getting a common denominator here, minus 6 pi, or 9 pi, excuse me, 9 pi over 6. That's negative 8 pi over 6. That's negative 4 pi over 3. Okay. So that's quite a bit. This is 2 pi over 3, so if we were to go that same amount in the other direction, which I'm kind of messing up there. This would be negative 2 pi over 3. We need to go to negative 4 pi over 3. That's twice as far as negative 2 pi over 3, so I am just going to take all of this and I'm just going to shift it over. Should have given myself a little more room. Now I have. So 1, 2, 3, 4. So negative 4 pi over 3 is where we are, right there. Okay. So that's where, man, that's where this point shifts to. That's like the right side of this period. Okay. You know, we could, we know that this shape is going to repeat itself. All right. So we could just follow this same pattern here. We know that the period is going to be 2 pi over 3. This is a full 2 pi over 3. Okay, so this would be negative 3 pi over 3, so that's negative pi. This would be, let's see, negative 5 pi over 6. And negative 7 pi over 6. And then we can just go through the full period just like it would look So here's what I did. Took this point, moved it to the left, 3 pi over 2. That came way over here. If I kept shifting these points to the left, I'd be even further over here. Okay, but the thing we know about the sine waves is it's going to keep repeating past that point. So that's what I said I would do. I know that the period is 2 pi over 3. From negative 4 pi over 3 to negative 2 pi over 3 is 2 pi over 3. So I just marked off points in between and put some points at the maximum, the midline, the minimum, and the midline again, and sketched it out like that. All right, so that's something else that we could do. But we shifted it up 4 by putting that midline there. We figured out what the period should be, and then we moved everything over 3 pi over 2. And yeah, that makes it a little easier to do. And you definitely want to figure out the period before you shift it at all. Figure out the period first. Mark off some points, then move them over. All right? All right, I mainly picked this one because of the negative that's in front here. That's going to flip it vertically, right? So we've got this check. We can do that. No problem. We've done that a couple of times, right? That 3 there is going to be a shift up 3. Yeah. Amplitude's the same, hasn't changed. 1, 2, 3 up because of the plus 3. Amplitude is still 1. Okay, so it'll come up here to 4, come down here to 2. It's going to move to the right 4 pi over 3. So let's mark these off at pi over 2, at pi, 3 pi over 2, and to 2 pi. Alright, so again, just normally it would look like this. It's going to go like that. That's not so good. Let's see, it should come up to there, midline, minimum, midline again. So it should look something like this, except for better than that. But it's going to move to the left. Okay, so it's going to move, or sorry, to the right, 4 pi over 3, and then it's going to flip upside down. That's what that negative does. The amplitude's still 1, but now it's flipped upside down. Okay, so let's get rid of that and those points, and we will start from here. Let's see, maybe we'll put the points that we would normally have since it's flipped upside down. We'll go like this, and then we'll shift them to the right. Okay, so this is what a flipped upside down sine graph would look like, and now we're just going to move to the right 4 pi over 3. Okay. So let's see, if we want to do it visually, this pi right here, if we divide it into 3 pieces, each of those pieces is a pi over 3. So if we mark off the pi over 3s, which we could do a better job of if we had a better eye. Let's see, we'll mark off another pi over 2, pi over 2, pi over 2, pi over 2. So this is going to be 3 pi and 4 pi, and this is going to be 5 pi over 2, and this is going to be 7 pi over 2. And we'll divide each pi into 3 pieces, so we can count by pi over 3s. We'll go about it that way. So move this over 4 pi over 3, so 1, 2, 3, 4 pi over 3. So that is this guy right here. Then move this guy over 4 pi over 3. 1, 2, 3, 4 pi over 3. Oh, I've counted them wrong. It's already at the pi over 2. So we're going to move it over 4 pi over 3. Let's see, 1, 2, 3, 4 pi over 3. Yeah, it's right there. Okay. Because these are also pi over 3 marks. Right, and we'll move this one over to 4 pi over 3 from there. So we'll go over 1, 2, 3, 4 pi over 3. We're back at the midline. We'll go up to this maximum, and we'll go from, this is at 3 pi over 2, so we'll go over 1, 2, 3, 4 pi over 3. We're at a maximum there. And here we're moved over 1, 2, 3, 4 pi over 3. And there is a single cycle. I'm going to check this one. Let's see, that one came from 3 pi over 2, 1. Oh no, those aren't going to work. This one and that one are off. Okay. So I'll just take pi over 2 and add 4 pi over 3. That's going to be a common denominator of 6. We're going to multiply this by 3, so 3 pi over 6. Multiply this by 2, so that's 8 pi over 6. So that's 11 pi over 6. 11 pi over 6. This is 12 pi over 6. 11 pi over 6 is right there. So this point should be here instead of there. So that's wrong. And this one should be, it moved from 3 pi over 2. Okay, so 3 pi over 2 plus 4 pi over 3 is moving 4 pi over 3 to the right. Get a common denominator of 6, so that's going to be 9 pi over 6 plus 12 pi over 6. No, 8 pi over 6. So we get 17 pi over 6. 17 pi over 6. Let's see, 18 pi over 6 would be 3, so 17 is right there. So this point should be right there. So that, get rid of this part of the curve, make it a little bit better. Okay, that's a little better. Okay, so this is a lot like the piston problem, except for it's a buoy. Right, but the idea here is the same. We've got a cosine wave, right? It starts at its maximum and then goes down and up like that. Let's see what's changed. Well, its amplitude is 5, right? And its period is 5 as well, 5 seconds. This is 5 feet. Okay. Well, its amplitude has changed. Its period has changed. It has not shifted to the right or left, though, so we don't have to worry about that. It has not shifted up or down. We don't have to worry about that. Its midline is still on the x-axis. So we're going to write an equation that looks something like... let's see. Its amplitude has changed, so something times the cosine of x minus something. All right. No, we've changed its period. So the period will be b times x. So you gotta figure out what a is and what b is. All right, so the a, that's easy, right? It hasn't flipped upside down, so it's just a positive 5 times the cosine of what? What times x will give it a period of 5? Well, we know a period is equal to 2 pi over b. So the period is 5. That's equal to 2 pi over b. Now we just solve for b. So we'll multiply by b on both sides, and then we'll cancel that b. We got 5b equals 2 pi, and b equals 2 pi over 5. Okay, so b is 2 pi over 5, so 2 pi over 5 times x. So now it has a period of 5. This is an amplitude of 5, and we're all good to go. All right. Thank you for watching.